Hello everyone. This is the experiment for the crossed-aldol reaction. Here we see the TA is acquiring 1 milliliter of para-anisaldehyd, and they are pouring that 1 milliliter into a test tube. Next we see that the TA is getting the acetophenone and also acquiring 1 milliliter of acetophenone. And that is, there's our 1 milliliter. And it's about to be added to this same test tube that had the para-anisaldehyd. Next up, we don't see it yet, but the TA is getting our 95% ethanol, and we'll acquire 3 milliliters of that and pour that also into the same test tube that currently has the 1 milliliter para-anisaldehyd and the 1 milliliter acetophenone. Alright, all of that is being, it doesn't look gentle, but it is being gently mixed together in the test tube. I have actually sped up this video, so instead of you having a 20-minute video, we have just shy of a 9-minute video. It is being mixed. Sir, mix a lot. Alright, now with the 50% sodium hydroxide, the TA is going to use the transfer pipette and is going to add dropwise the sodium hydroxide. But before that can happen, you've got to hit that bottle. And here's our dropwise addition. I'm adding approximately 5 drops with the transfer pipette. Now this mixture is mixed a lot for approximately 2 minutes. Remember, we're not actually going to sit here and watch this test tube go crazy for 2 minutes, but it is being mixed / swirled. Alright, now the TA has grabbed a beaker, and that beaker, as we can now see, has had ice water added to it for an ice bath. So we're adding the entire mixture of anisaldehyd, acetophenone, ethanol, and sodium hydroxide to the ice water bath to cool it down to help facilitate the production of crystals. And what you can't hear, since I have removed the audio, but what you can't hear is they're also using that glass stir rod to scratch the side of the test tube to help induce crystal formation. And so one thing I do want you to pay attention to, you can sort of tell, but in the beaker you see that yellowish solution. It's transparent. You can actually see through it. But once they have tried scratching, oh look, there you go. Now you can see it. Well, get your arm out of the way, playa. Alright, but you can kind of tell how it does look very transparent. Once they are have let it sit in the ice water bath and they continually scratch the side of the test tube to induce crystal formation, you'll see a very murky solution where solid has begun to precipitate out. You can tell it's starting to get a little murkier. if you'll ever get your arm out of the way. Just kidding. I really don't want you to see it. No. Oh, there it is. You can sort of see. You'll see it. They'll give you a nice clear view in a second. Oop, there it is. Think fast. Alright, so at this point, they are going to collect, well, sorry, they're going back to scratching it some more. They're not happy. They want more crystals. But what's about to happen, you'll see them pull out a Buchner flask with one of those porcelain Buchner funnels so that they can collect this resulting solid or crystal using vacuum filtration. And you can thank me later. I have taken out the audio, so the annoying noise of the vacuum pump you're not going to hear, just the sweet melodic sound of my voice. Alright, so they're pouring it out of the test tube, and you can see they're collecting the excess solvent and solutions in the bottom of the flask. They're adding some cold water to help get any extra solid that's stuck to the original reaction test tube. And then they're going to try and clean off some of the solid by pouring some more cold water over it. Hey, look in that funnel. You can't see anything, but it's there, I promise. Alright. So this has been time-lapse, so certain clips of this have been taken out for time constraints. But it has been allowed to be on the undergo vacuum filtration for quite a while. So now the crystals are as dry as they can get via vacuum filtration. And then they were allowed to air dry for an additional amount of time. AKA, we throw it on the hot plate and heat it up some so that we can speed up the process. I mean, technically that's air drying. Alright, so they're about to take the melting point range on the Digimelt. And so, as you should hopefully recall, you're going to use the capillary. You're going to just kind of dot it on the solid and then tap the capillary to get that solid at the bottom, the closed end of the bottom or the closed end of the capillary tube. You know what? We want a lot of solid, so we're going to keep loading that capillary tube with solid. You thought I was going to show it to you, but I didn't. And so another thing we can do is use the little tapper that's on the Digimelt. Alright, turn the Digimelt on, and you won't actually be able to see the melting take place, but they saw it.